Hello students. So today I am going to discuss one fluid mechanics problem. The question is, there is a circular tube in a vertical plane. Two liquids which do not mix and of densities d1 and d2 are filled in the tube. Each liquid substance 90-degree angle at center. Radius joining their interface makes an angle alpha with vertical. Ratio d1 d2 is what? So these are your options. So let's proceed. The given configuration of the liquid is like this. Here both the liquids subtends 90-degree angle at the center. This radius vector makes an angle alpha like this as shown in the figure. So let me consider one point at the bottom of this circular tube. Then since in this space there is nothing, both are exposed to same atmosphere, so here also the pressure is P0, here also the pressure is P0. So we can write the pressure at point A as, from this side we can write the pressure as P0 plus the pressure due to this column of the liquid. The density of this one is D1 and density of this one is D2. So P0 plus rho G H1. So H1 is, here the H1 is the height, this height to this. So we need to find out this height. Since this angle is alpha, this angle is also alpha. So if we see, this angle is alpha, this is R. The configuration is something like this. So this will be your R sine alpha. Okay, so this is the required height. This whole length is R, so height will be equal to R minus R sine alpha. So we can write this pressure as P0 plus D1 G R 1 minus sine alpha. So this is my first equation. Next, I can also write the pressure at point A as P0 plus the pressure due to this column of the liquid. But in the right side, this contains two parts. One part is from the liquid of density D1 and other part is from the liquid of density D2. So P0 plus, for this liquid, the pressure at this point, we can find out, or we can calculate. This is H2, suppose P0 plus D2 G H2, and if this height is H3, then plus D1 G H3. Now for this, let's draw a perpendicular on this. If this angle is alpha, then this angle is alpha. So from this triangle, if this angle is alpha, this is R, so this will be your R sine alpha, and then this, from this triangle, this will be equal 90-degree minus alpha, so this will be your R sine 90 minus alpha, this will be your R cos alpha. So total height H2 will be your P0 plus D2Z R sine alpha plus cos alpha, okay, plus D1 G H3. Now for H3, from this triangle, we can find out. This is like this, something like this. Configuration is something like this. Okay, this one. So this is your R, this is your alpha, so this much is your R cos alpha. This is the required height h3, so we can have the h3 as R minus R cos alpha, R minus R cos alpha. So if you write this, P naught plus d2g R sin alpha plus cos alpha plus d1g, for h3 we will write R into 1 minus cos alpha. So this is the expression for pressure at A by the right liquid column. So from equation number 1 and 2, if we equate these two equations, then we have P naught plus d1g R into 1 minus sin alpha is equal to P naught plus d2g R sin alpha plus cos alpha plus d1g R 1 minus cos alpha. P naught cancel out, so d1g R taking common 1 minus sin alpha minus 1 plus cos alpha, bringing this in the left side. So we are left with d2gr sin alpha plus cos alpha. This implies d1 gr got cancelled, cos alpha minus sin alpha is equal to d2 sin alpha plus cos alpha. From this, d1 by d2 is your sin alpha plus cos alpha divided by cos alpha minus sin alpha. Dividing both the numerator and denominator by cos alpha, we have 1 plus tan alpha 1 minus tan alpha. Divide whole of this by cos alpha and this by cos alpha. This will give us 1 plus tan alpha by 1 minus 1 plus tan alpha 1 minus cos tan alpha. So this is the required option. So the ratio of densities of this liquid in the circular tube will become 1 plus tan alpha by 1 minus tan alpha. So the correct option is option 2, 1 plus tan alpha by 1 minus tan alpha. Thank you.